So we said yesterday that a typical question, if they want us to find the acceleration of everything, we'll write an equation for everything, usually along the rope. And then if they want us to find an individual force, like tension, we'll write an individual equation for an individual mass to find an individual force. Let's look at example 3. I like example 3. Actually, example 3 is a little too easy as well. The reason example 3 is a little too easy is these wheels right here. I think having friction as part of this would make this a better question. But for now, it says, okay, if we have a hanging mass like this and no outside force, which way must this accelerate if it's going to accelerate at all? Is there any way in this setup that on its own, this little 6 kilogram car would start pulling the 2.5 kilogram mass up? Okay, so you're going to accelerate down and right. Now, if there was no wheels here, there would be friction. The other possibility is friction is so big that this just dangles and stays at rest. But those are the only two possibilities. It's not like somehow it's going to start accelerating that way. Okay. Cool. Gershine, what does part A want me to find? And what does part B want me to find? You know what it was a good job for? Let's do it. More than one mass, yeah. What are the forces acting on the 6 kilogram mass, folks? Get the obvious one. Is there more than one mass in this question? So how did I label it last day? M1G. Are we sinking into the ground like quicksand? Are we flying into like Superman? No? So what else? And I called it normal force number 1 to go with mass number 1. What else, folks? What you're feeling right now, a little tension? Yeah, this rope is tugging with tension. Is there friction? I think the wheels are supposed to get me to assume no friction. Okay. Any other forces acting on mass 1? I don't think so. So, what are the forces acting on mass 2? Get the obvious one. I'll call that M2G. What else? Is there a normal force acting on mass 2? How do you know instantly there can't be any normal force? It's not sitting on a surface or leaning against the surface. What else? Which way? Yep. Which way is this accelerating? I think down and right. Yes? Who's winning? Down and right. So anything, once it gets to here, anything that ends up pointing down is going to be winner plus. Anything that ends up pointing up is going to be loser minus. Same as before, Lena, I'm going to write an equation along the rope, except there's going to be a 90-degree turn because of that pulley. And in fact, all a pulley does is it changes the direction of the force. So I still follow the rope. Who's winning? More specific, as a force in my free body diagram for part A, who's winning? Which one? There's 2 of them. Who's winning? Can someone just read to me exactly what? M2G. Winner. Now let's walk along the rope. I run into this T, this tension. Winner or loser? Winner plus or loser minus? Loser minus. Keep walking along the rope. Now, this tension here, if I follow it, when it curls around down here, which way will it be pointing? This tension here, which way will it end up pointing when it gets to here? Winner plus. Have I reached the end of the rope? Don't I have to put M1G in? Is it along the rope? Then no. Equals. What does winner minus loser always equal? What about when there's more than one mass? What's the little tweak we did? If we have forces from more than one mass, we said we better have more than one mass. Oh, come on, folks, stretch it out. Why are we stretching? What? Why are we stretching? Why are these questions so relaxing? Oh, you get to lose a little tension. Oh, it's like spa treatment. What does part A want me to find? Nick, how am I going to get the A by itself? Divide by M all. So I think you're telling me A is going to be M2G divided by M all. And of course, Nick, you're not going to try and memorize this equation. That's unique for this situation. I'm teaching you how to derive these from scratch. It's a better way to get to. All right. Gershine, what was M2? What was G? You'll notice in the top, the 6 doesn't appear. It does appear in the question, though, because M all is 6 plus 2.5. That 6 is slowing this down, but it's not contributing a new force. It's just slowing it down due to its inertia, which is why it ends up in the bottom. This is a fraction. What do you get? Oh, stop. Look up. There is a built-in error check. Anytime you have a hanging mass, if I were to cut that rope right there, what's the maximum the acceleration could be? I know this is going to be less than 9.8 because this 6 is slowing it down. So if you get an answer bigger than 9.8, panic a little. Well, go check look for a typo. 2.5 times 9.8 divided by bracket 6 plus 2.5. I get 2.88. Gershine, units, it's an acceleration. Direction, I won't ask because there's two directions. One mass is accelerating right, the other mass is accelerating down. This is why acceleration is a vector, but you'll notice I haven't been really asking for directions. I'm typically just finding the magnitude of the acceleration because stuff is accelerating in different directions here. Is that okay? Can't be turning the page yet, Dan. There's a part B. What was part B wanting me to find? Dan, what was part B wanting me to find? Okay. I'm going to phrase that slightly differently. It wants me to find an individual force. You know what I'm going to write? An equation for an individual mass. Just to show you that both work, draw a little line down the middle of the page. We're going to write both equations, and I'll have half of you evaluate each one. Let's, first of all, Dan, write an equation for mass 1, the 6. Which way is it accelerating? Which way is the winning direction? Same answer. Which force is winning? Which way is it accelerating? To the? Which way is the winning direction? To the? What's the only force on mass 6 that's pointing to the right? Which force is winning? That 6 is not a force. Look at your free body diagram. Don't tell me a mass is a force. See the free body diagram? There's only one arrow pointing to the right. Which force is winning? Psst. Psst. Yes. Okay, right? You know your difference? Okay, the right hand is the one you shoot with. The left hand is the one you don't know how to score with, right? Basketball, okay? I watch your layups. Ugh. Or are you a lefty? Okay, so ready? Which way is it accelerating? To the? Right. You're way overcomplicating this. That's why I want to walk you through it again. So which must be the winning force? To the right. Which force is winning? And I don't care about these. I'm only looking at mass 1. So who's winning? Who's losing? Anything pointing to the left. It's a trick question. No loser. What's it going to equal? Which mass are we writing an equation for this time? Mass 1 or mass 2? Come back to that. Or, just for giggles, Ange, you could have picked mass 2. Which way is mass 2 accelerating?
Down.
The good news is, at least you didn't say right. One of those 3 answers, left, up, or down, is correct. Let's try that again. Scene 1, act 1, take 2, and action. Ange, which way is mass 2 accelerating? Your line is down. Yes, down. So which way is the winning force pointing? Same answer. Which force is winning? Okay? Winner. Is there a loser? Which way would loser direction be? The opposite of down. I don't know if you saw that, Gershina. Which way would loser direction be? And she actually did that. She pointed at you. Stop. We're not going to go to mass. We're just writing an equation for an individual force. Do an individual mass. What's that going to equal? Which M? Did we have forces from everything in here? That's a bad guess. Which one are we writing an equation for? Yes. Okay. Here, the T is by itself already. In fact, if I was solving for tension, I would have used Dan's equation because I would have thought both of them in my head and said, I'm lazy. But, Ange, how would I get the T by itself here? What? No. What's right in front of the T that I don't like? I'm not going to minus the M2G. I'm going to leave it where it is. I'm going to swappy dance, my angel. Right? So don't move the M2G around. It drops down like a domino. But I'll have a minus M2A. That equals tension. So over here, tension is going to be M2 2.5, G 9.8, minus 2.5 times, I'm even going to write answer button. Over here, tension is going to be 6 times answer button. This half of the class, can you go 6 times answer button on your calculator? This half of the class, can you go 2.5 times 9.8 minus 2.5 times answer button? We should get exactly the same thing. Did you all get 17.294111765? Okay. If you didn't, you made a typo. Which one of those would have been easier to find tension with? I would have gone with that. So what you want to do, if they want you to find an individual force, look at your situation, pick whatever's easier. 17.3 newtons. Dan, is that okay? Yeah. Okay, so again, before you turn the page, you can turn the page, but just to review, if you give me many masses, if you ask me to find acceleration of everything, write an equation for everything. If you want me to find an individual force, I look at an individual mass. I like example 4. Example 4 is a nice question. Now we got a little friction. It says, find the acceleration and the chord tension. We can handle this. Not a problem. Psst. How do you think I'm going to start? Darn right. Did they give me a picture? I'm going to label the picture. I'm going to start on the left because I just typically go from left to right. So, okay. Emma, what are the forces acting on the 3.2? I'm going to call that M1G since there's more than one M. What else? I agree. Same size, I think, and I'm going to call it normal force number 1. What else? From a rope to the right. What else? To the left. You know what? I'm going to call it friction force number 1 to go with mass number 1. Any other forces on the 3.2? Nope. What are the forces on the 2.8? Get the obvious one. I'll call that M2G. What else? What else? Nothing. Good. I knew I could count on you to have enough courage. Nothing. No normal force. Okay. Which way is this accelerating? Well, we've got a mass hanging over a cliff. If it's going to accelerate at all, it's going to be right and down. It's possible that right here friction could be so big that this 2.8 is just dangling. Although, Emma, how big is mu? This is really slippery. I'm pretty sure we're going over the cliff. What does A want me to find, Emma? Of everything. I'm going to write an equation for everything. Who's winning? Did I give you a whole page for this? I think I did. Okay, good. I'm going to scroll down. Which way are we accelerating? Right and down. What's causing this whole thing to start accelerating? Which force on the free body diagram is the instigator here that's really causing this to start to accelerate? Yeah. Yes. I'll start there, Emma. And again, I'm going to write an equation along the rope. So there's going to be a 90-degree turn when I get to the pulley. Who's winning? Emma, my angel. Keep going. Good. Keep going. Good. Keep going. Friction force number 1 that goes with mass number 1. Do I need to put M1G? Is it along the rope? No. Equals what? M all A. Put your pencils down. Stretch it out. Come on, you know you want to. Oh, Mr. Dewick, these are little spa treatment questions. Oh, I should pay money to do these. Emma, why am I stretching? What's A asking me to find? You know what? I'll use Nick's theorem right away, too. Okay. So A is going to be M2G minus... What can I substitute in for friction? Friction is what times what? Oh, mu times... I don't know the normal force. Oh, but look. I know the force is the same size as the normal force. Which one? Which M? Can you see if you're not careful, it's easy to get M's mixed up? Yeah, so that's why I'm being fussy. All over, and what do I mean by M all? M1 plus M2. Do a quick check. Emma, do I know M2? Do I know G? Yep. Do I know mu? Yep. Do I know M1? Yep. Do I know G? Yep. Do I know M1? Yep. Do I know M2? Yep. Plug and chug. I mean, a little bit complicated plug and chug, but still plug and chug. Emma, I've scrolled down completely. What was M2? G, I know, is 9.8. Not negative. We took care of that with our winner minus loser. Minus, what's mu? I don't know what's mu with you. What was mu? 0.12. M1 was? G, 9.8. All divided by 3.2 plus 2.8. That's about as complicated as we're going to get, so you should try typing that in for practice. Of course, I didn't need to remind you to type that into your calculator. You would have just done that every time automatically because you want to get a good grade in my class, and it would be silly to be able to solve the question and still get the wrong answer because you hadn't bothered typing it into your calculator. Right? Right. Oh, built-in error check. I know A is going to be less than 9.8 because if I cut the rope, that dangling mass, the maximum it can accelerate is 9.8, and it's getting dragged slower by friction from that upper mass. Let's see, Mr. Dewick. Bracket 2.8 times 9.8 minus 0.12 times 3.2 times 9.8. Close off the top, divided by 3.2 plus 2.8, close bracket. Are you starting to see why at the beginning of the year I was yelling at you about learning how to get good on your calculators? This is why those of you that are still showing times with brackets, it's so much more confusing. I can read what's on the top because it's inside that first bracket. I can do a quick error check. I can read what's on the bottom because it's inside that second bracket. I don't have extra brackets kicking around if I don't need them. Y'all get 3.9461333. I'll go 3.9 what?
5.
Okay. Cool. Keegan, what's B want me to find? Look at the two masses. Which one would probably be easier to solve for tension? In other words, I think here, there's one mass that looks way less cluttered. I would use mass 2. I would. You'll get the same answer for mass 1. Mass 1, it would be tension minus friction equals M1A and get the T-bytes. I'm going to use mass 2 because there's fewer forces on it. Which way is mass 2 accelerating, Keegan? Give me an equation. Equals, because we're just doing one mass to find an individual force. Individual mass equals what? Which M? No, we're doing an individual mass. Sorry? Which M? Yes. Not M all. Then I'd have to include the forces from mass 1 and that on the left-hand side. I only have forces from mass 2. I better only have mass 2. I have forces from, let's go up here. I have forces from both masses. I better include both masses. And how would I get the T by itself? Swappy dance, because what's right in front of it? Ugh. I'm not going to move the M2G over. I'll move the M2A over. In fact, I'll get this. M2G minus M2A. Keegan, do you mind if instead of saying equals T, can I put T equals there? And let's keep going. Keegan, I've scrolled down. What was M2? Sorry, I missed that. Thank you. G, 9.8 minus 2.8. Times, what was A? Oh, I'm going to write 3.95, but what button am I going to hit on my calculator? Darn right, less typing, more accurate. 2.8 times 9.8 minus 2.8 times answer button. How big is tension? 16.4 newtons. So to find tension, you need to find acceleration first. I would feel okay, Ashley, giving you this same question, but not asking part A, simply saying, find the tension. And I hope you would clue in, well, actually, I need to find the acceleration of everything first. Winner minus loser equals M all A, and then find an individual force from an individual mass. In fact, believe it or not, we can even handle 3 masses. I'm not going to give you a 3-mass question on your test. I think there's one in the homework. It's just too much work. We can handle it. Okay. So I'm not going to say, I like example 5. I'm not saying that. We can handle it. Reed, what's part A want me to find?
Acceleration.
Okay. Any thoughts on how I might want to start? Darn right. I'll start on the left. Looks like I'm going to have M1G. Yeah. What else? You know what? In this question, there's more than one rope. There's a left-hand rope and a right-hand rope. So you could either call it tension left and tension right. I'm going to call it tension 1 and tension 2. I'm going to say tension 1. What are the forces on this middle mass? Get the obvious one. M2G. What else? Normal force number 2 to go with mass number 2. What else? We'll come to tension 2 in a second, but first I would also say forces come in pairs, tension 1. What's pulling this mass forward? Tension 2. And we've missed one force. Everybody see it? Friction. Ooh! Which way will friction point? First, I need to figure out which way this 9 kilogram mass is going to slide. How do you know it's going to slide to the right? Sorry, your right is this way. So how do you know it's going to slide that way? The 8's bigger than the 1. And I think it's reasonable for me to assume you know enough physics to figure that out on your own. So friction. I'm going to call it friction force 2 to go with mass number 2. What about the 8 kilogram mass? Get the obvious one. M3G. What else? Which tension? Yep. I mean, 3 masses, it's going to be a lot of work. Maybe as a bonus question I might feel okay, but I'm not going to throw it on the test for marks. Who's winning? M3G. This is what's causing this whole thing to start to accelerate. So anything that ends up pointing down, once it gets to this side, is going to be a winner plus. So let's walk along the rope. We have winner. What about this tension 2? Winner plus, loser minus. Loser minus. What about this tension 2? Follow it, follow it, follow it. I think when it gets here, it's going to be pointing down, which we've said is winner plus. What about friction force number 2? Loser minus. What about tension 1? Loser minus. What about this tension 1? You got to be careful because you might be tempted to say, well, it's pointing up. Tension 2 was pointing up and it was a winner, so tension 1 is a winner. But look, if you follow it, follow it, follow it, follow it, follow it, I think when it gets over here, I think it ends up pointing down. I think this particular tension is winner plus. Same with M1G. You might be tempted to say, well, M3G was pointing down. I called that a winner, so this is a winner. But if you follow it, follow it, follow it, follow it, follow it, I think when it gets to this side, it ends up pointing up. I think it's a loser minus. Hey, what's that going to equal? What do I mean by M all this time? M1 plus M2 plus M3. Oh, double spa treatment, Mr. Dewick. Oh, wow. Gone, gone. Whew. That felt good. Hey, Nick, how am I going to get the A by itself? Nothing new. You feeling brave? Let's see if we can go straight to numbers. M3. G. Minus, up here, I'm going to cross out friction force number 2, and above it, I'm going to write mu times normal force number 2. Ooh, I don't know normal force number 2. Or do I? What's normal force number 2 the same size as? So I might even cross that out and go M2G. And now I can plug in numbers here. I would never do it this fast on a test, but this is probably how I do it in my homework. On a test, I'd write at least one more line before I start plugging numbers in. Brea, what's mu with you? I don't know. What's mu with me? What's mu? 0.25? What's M2? 9? Yeah? 9? Yeah? Yeah, 9? Yeah. G? And then minus. Ooh. Nick, what's M1? 1. G. All over 1 plus 9 plus 8. Of course, by now, all of you have picked up your calculators because you're realizing it would be foolish if you were able to write this out and you couldn't actually find the correct answer. That would be the epitome of silliness. This is a fraction. Hey, definitely brackets around the top and definitely brackets around the bottom. Again, I know the acceleration here is going to be less than 9.8 because if I cut the rope, that's the maximum it could be. Do y'all get 2.586 and then 1's repeating? Okay. All right, 2.5 what? Yeah. Then it wants us to find tension. I'm going to find tension 1 and tension 2. I'm just going to kind of split the page. Which mass do I not want to use to find tension? M2, because it's just cluttered. I could. Do yourself a fave and pick one that's less cluttered. So, Mud, look at mass 1. Which way is accelerating? Which way is winning then? Same answer? Who's winning? First of all, M1's not even a force. That's a bad guess. Don't tell me a force. Don't tell me a mass is a force. Look, and I'm deliberately, you have to look at your free body diagram. Look at it. Which way is mass 1 accelerating? Who's winning? The force that's pointing up. Yes. Who's losing? The force that's pointing the opposite of up. Which M? So if I hear you finally, are you telling me tension 1 minus M1G, that equals M1A, because we're just writing an equation for that mass? Yeah. How would I get the tension by itself? No, there's no negative in front of the T. This is definitely not swappy dance. I'll ask again, how would I get the T by itself? I'll plus the M1G over, but I'll not swap things. It's going to be, what was M1? 1? What was A on my answer button? Plus 1 times 9.8. What do you get for tension 1? Mud, what'd you get? Oh, I can do this in my head because it's actually just the 1 times table. It's going to be 9.8 plus 2. It's going to be 11.8 plus 0.5. It's going to be 12.3. 12.39? Yeah. 12.4? Newtons. Okay. Taryn, which mass would I use to find tension 2? First of all, which mass? M3. That's not a force, so don't say M3G. Which mass? M3? Yeah. Which way is M3 accelerating? Which way is the winning direction? Same answer. Who's winning? Who's losing? Equals. Yes. Do you hear it? M3G minus tension 2 equals M3A. How will I get the T? Oh, this is a swappy dance. Right? And I'll get this, and I'll also run into a bit of a problem here. The problem is I can't use my answer button anymore, because now my answer button has the 12.39 on it. So what are my options? You might, if you have a good calculator, it might actually be able to go back more than one line. You might, so for example, on mine, if I had gone 1 times answer button plus 1 times 9.8 and got that, I can actually go back 1, 2 lines and store that answer again. If your calculator can do that, great. Who has a Casio newer calculator? I just found out this morning that some of your calculators actually store 2 answers. You might have a previous answer. Apparently, if you hit alpha button and then either equals or answer or something, that brings 2 answers ago. If you have that, you're smiling because you still have that 2 point whatever story. The rest of you will have to just round off a bit. Anyways, I'm going to go with, because I have my answer button, T equals, what was M3? 8 times 9.8 minus 8 times, I'm going to write 2.59, and some of you will type 2.59, but I can still use my answer button. And I get exactly 57.711. I'm willing to bet those of you that use the 2.59 got 57.6 or 7 or 8. You're within 0.1. And I'd be fine with that on a test. Whew. Is that okay, Jan? Yeah. You copying it okay? I'll pause for you. You got it all right? You sure?
Yeah.
I should do this during the earthquake drill. That would add to it, wouldn't it? No? Okay. Try number 1. If you get number 1 right, you can skip number 2. If you get number 1 wrong, you can do number 2 because it's identical to number 1 and you need the practice. Try number 3. Ooh, friction. Under both of them. Ooh. Try number 5. Ooh, number 6, like number 5, but with friction. Number 7 is tricky. A is okay. So number 7 gives you this. We kind of looked at one like that. It wants you to find the acceleration of everything. Hint, treat this like a 14 kilogram mass. But then B says, find the coefficient of friction of the 2 kilogram mass right there. See if you can figure that one out. That is far tougher than I'll ask you. This is actually an old Physics 12 scholarship question, but see if you can have the aha moment, or I'll talk about it. Eight is good. Ooh. Number 9, what are they asking me to find? Okay, you're going to still go free body diagram, who's winning, who's losing, but you know what you're going to get by itself this time? What are they asking me to find? You're going to get the mu by itself. I haven't done one like that on purpose. I'm curious to see if you can figure it out yourself. And same with number 10. Put a star next to number 12. So what I'm saying with number 7 and number 12, if you can't get those, not on your test, not going to be anything that tricky on your test. This is really for those of you who are like nerds and really like a puzzle or a challenge. Okay? I've thrown a lot at you. We're almost done. I only have one more lesson and we're done the unit. I got a couple of more take-home quizzes, but right now I'm thinking your test is going to be end of next week, beginning of the week after. Okay? We have come a long way, my friends. I was going to show you a couple of short videos. I want to give you 10 minutes just to work on this. We'll bring in some other stuff another time. Thank you for your patience. That was lots of me talking.